So now we've got a 2D image that I've kind of put into Excel. I've got the input, and once again, each one of these cells can range from 0 to 255, 0 being the lightest and 255 being the darkest. And my processed image is over here. I've kind of got this border of black, and that's because we can't really compute the value of this pixel because that would also be calculated off of these pixels on the side here, which we don't have data for. So I'm just gonna kind of for this case I'm just gonna leave them black, or 255. Now, I've already gone through and programmed these cells and kind of figured out how they should be calculated based off of their neighboring pixels and the kernel in our scalar here. So just to show you, this pixel right here, which is kind of related to this pixel right here, is calculated off of its neighboring pixels. And it's also, for example, if we look at this very first operation here, we have B2, which is right here, is multiplying K3, and then it's adding to the rest of it. And then we've got L3 is multiplying C2, and then that's getting added together. And I just took that, and once again, the values that I want to stay constant, i.e. the kernel, I don't want them to move, and so I use dollar signs here to make sure that it's always referencing K3, L3, M3, so on and so forth. So I went through and I just scaled that to each pixel or each cell here, and so I'm pretty much ready to do my simulation. Right now I've got the something called the identity kernel in here, and so this identity kernel just means that whatever I put in will also be my output. So for example, if I do something like just a single pixel here, let's call it 200, and there it is. I managed to get it on my output. So let's do something interesting. Let's do a shape. Let's kind of do a really basic circle. Alright, so I've got, we'll make it a little bigger. So these 4 pixels here are going to kind of be the center. So I realize this is a very blocky circle, but it's about as circular as we can get in this environment here. So our identity filter is still working, right? We still get in what we put out. Let's try and do something different. Let's try and blur this, or apply blurring filter. So that's, once again, there's a couple ways that we could go about blurring things. This is just one of them. And then you see this is actually getting really dark. That means we need to change our scalar here. It turns out that this one should be 1/8 or 0.125. And check that out. So we kind of, maybe that scalar should be a little less because we have a large value there, 0.2, or we got 225 there. But either way, you still see the effect that this, it's almost like we dipped a pen in ink and touched it to some paper, and it was allowed to kind of soak in and kind of distribute. That's what we expect our blur to do, right? It kind of makes these edges here, which were previously very sharp, much softer, right? And so you can kind of see it's distributed across the whole image now. Let's do another filter. Let's do a left Sobel filter. So we want to find the left edge of our circle here. So to do that, we're going to change our scalar up just a little bit. We'll do 0.25. And let's put it in. So -1, -2, -1, 0, 0, 0. And this just needs to change to 2, and we're good. So we see here now that this this left edge is darker, and so this is indicating, right, that the darker pixels is where our left edge of the shape is. So if I kind of change the geometry, this left edge, right, we're still able to detect that. Whereas if this scales out further, the right side, we're not picking that up at all. This guy right here we might pick up because it does have a left edge available. So we're kind of see that this stretch here is our left edge. So hopefully you see that this concept actually isn't that hard. Doing it really programmatically, like in a program, isn't super hard if you have the ability to just read a pixel's data and its neighboring pixel and have functions to build images. But that's why it's nice to kind of work through this concept first in something like Excel, because it's very approachable and it handles all the arrays and all that stuff for you.